Hello everyone, welcome to the crash course, and this is the lecture for the inorganic chemistry, and myself Prashant Parikh. I'm here to teach you the inorganic chemistry. Today we'll just start up with some of the basic points. Okay, in inorganic chemistry we are not going to go in depth right from starting. Okay, we are going to go step by step. Okay, obviously that is the way you must study chemistry, because unless and until you won't climb the first steps, you cannot reach at the top, right? So in this lecture we are going to study the basics of inorganic chemistry, right? Now, as discussed in the earlier lecture, that what exactly inorganic chemistry consists of, so I'll elaborate a bit in this lecture, right? So in inorganic chemistry we are going to first study that how the elements were classified. Okay, like at the starting when the elements were discovered, it was not that all the elements which are known right now, they were discussed at the earlier point. If I talk about 100 years ago, these many elements were not discovered. Right now, if you talk about, there are 120 plus elements, and these many elements were not discovered in the earlier times. So as day by day the new elements were discovered, there were changes in the classification method of the elements, and there were changes in the laws put forth by different scientists, which we are going to study first. Okay, then at last we are going to study that which was the most suitable periodic table which is still going on right now, which we are using till now, and obviously it has got no demerits. Might be in future it may also have some demerits or some drawbacks which we might don't know right now, but till now it is one of the most suitable classification of the elements, right? So we are going to study it in a stepwise manner. Now the reason comes, why is it necessary to classify the elements, right? Why is it necessary to classify the elements? So obviously if I say you that there are 120 elements, you need to learn them all, or you must know their properties, you'll be like, sir, what you're saying? Is it possible? Obviously it's quite difficult. Okay, but after the completion of this lecture, or after the completion of this topic, you will be easily able to recognize the properties of the periodic table. If not, at least you cannot remember the elements, but you can tell me that what are the properties of this specific element or this specific group or period. Okay, what we are going to study. Now again, I'll share what is the inorganic chemistry. We are going to study about the elements which are found in the nature. Okay, what are the elements? The question comes in mind, right? Everyone must be thinking, elements, what is this, sir? Every time you say element, you are going to study elements. Okay, so let me tell you, each and everything around us. Okay, if I talk you from a small chalk, okay, to a large big whale, each and every particle, whether it is living being or non-living being, they are made up of some or the other elements. Okay, now if I talk about this chalk contains calcium. Okay, so calcium is one of the element of the periodic table. Okay, that is the periodic table, that is one of the element which exists on the earth. Okay, second thing, elements can be man-made. Some of the elements are man-made, okay, synthetic elements, and most of the elements are naturally occurring. Some are occurring in a very large amount and some occur in a very trace amounts. Okay, so there are different types of elements. According to the availability, we use them according to our uses. Okay, now let's come on to the topic that why we need to classify it, so that it becomes easy for us to understand. Okay, like if we talk about you have a 5-story or a 10-story building. If I don't number the rooms according to the floors or according to the sequence, it would be very difficult for you. If I give you a number and I say that you need to go to this room, it would become very difficult for you to go without any sequence, isn't it? So we require sequence to understand or to memorize or to learn anything, right? Sequence is very much necessary. So this thing started. This was the thing which was started, okay? And the scientist got interested. Let's arrange the elements in the sequence. And then the trend for inorganic chemistry, that is the arrangement of the elements, started. So we are going to study the stepwise that which were the scientists who gave their contribution. Okay, though they failed, but still they contributed in the classification of elements to some extent, not to a large extent, but to some extent. So we are going to study one by one about them. Okay, so in the queue, the first scientist, okay, the very first scientist who tried to classify the elements, okay, that was a very basic classification method, okay, which is we are still using it now, but it cannot be useful for classification of 120 elements, okay, but still we use it to some extent. So the name of the scientist was Lavoisier, okay, and his method of classification was very simple. He classified the elements based on thing, that is metal or non-metal. Okay, it is a very simple concept that metals are the elements, okay, metals are the elements which loses an electron or which easily donates an electron. Okay, now whenever, okay, always remember this thing, whenever any element, okay, whenever any element in chemistry loses electron, it gets a positive charge. Okay, whenever any element loses an electron, okay, it gets a positive charge. Obviously, how you will remember this? Like, why sir, he has lost the element, he must have got some negative charge. No, but how you must remember it? Like, suppose I am having 100 rupees. If I am giving this 100 rupees to someone on interest, obviously that's a profit for me, because after 1 month or 2 months I may get 105 or 110 rupees. Just approximate I am saying. Okay, so it's a positive, if it's a profit for me, right? The same way, the elements which lose electron, they get a positive charge, and they are known as metals. What they are known as? They are known as metals. Again, the elements which lose electrons or which easily donate the electron are known as metals. And now coming to the second one, that is the non-metals. The elements which easily accept electrons or the elements which accept electrons are known as non-metals. So let's take some examples of the metals and non-metals. Like if I talk about metals, if I talk about sodium, potassium, okay, these are the signs. Okay, Na stands for sodium. Okay, we are going to study this. K stands for potassium. Okay, don't get confused children, okay, what exactly this sign is. These are just the sign to denote, because we cannot write such big name in the periodic table, so we denote it through some of the other sign. So these are the signs for the elements which we are going to study in the periodic table. Don't worry, we are going to study. For now, you just remember that Na is for sodium, K is for potassium. So sodium, okay, when donates its electron, which charge it is going to get? Plus charge, positive charge. And what? The electron has been released from its outermost shell. Same you can write for potassium as well. Okay, same you can write for potassium as well. Potassium, okay, when donates an electron, it gets a positive charge. It's clear from here. Now what I'll call them? Obviously they have got the positive charge, so they are known as metals. What they are known as? They are known as metals because they have donated the electron and they have got the positive charge. It's a very simple classification. And if I talk about non-metals, okay, so if I talk about chlorine, bromine, okay, these are the non-metals. Now what happens? They will, okay, accept an electron, and obviously which charge they are going to get? If it's positive while donation, so it will be negative while accepting the electron, right? So they are going to get the negative charge. Okay, see children, always remember any of the element or any of the element is always neutral when it is not accepting or donating electron. What do you mean by neutral? Means what? It will not have any charge on it. Okay, it is always neutral when it's not having any extra electron, or if it has not given any extra electron to anyone, right? So this is the concept, and whenever they accept electron, obviously they'll get a negative charge, and whenever they'll donate the electron, they are going to get the positive charge. This concept will be helpful for you to determine oxidation number, which you might study in organic chemistry. Okay, and we are going to study in inorganic chemistry in transition metals. Okay, at that time you must remember this concept, like when a element gets a negative charge, which elements get negative charge, which elements get positive charge. Okay, like we are going to study it in a stepwise manner, but just for now I am just giving a hint that this is even useful in further classes as well. Okay, this will be useful. So these are the metals. So if I define metals and non-metals according to Lavoisier, so what he said, metals, okay, metals are the elements, okay, which donates their electron okay, which donate the electrons. And obviously, what are non-metals? Non-metals are the elements which accept the electron. Am I right? Am I right to this point? Any doubts, anything? No, I am clear till this. I've showed you the example as well, and why they are known as metals, why the positive sign comes. Okay, I've explained you in detail. So this was the Lavoisier's assumption, or he said that this could be the criteria to classify the elements. But is it the only small sign which you will find in an element? No, there are many things. Okay, it's not only electron which is the thing you can judge an element. Okay, so this classification has got some drawbacks. Okay, now what are the drawbacks? First of all, I'll tell you, there are some elements which shows both the properties. Okay, which shows both the properties. Now, it's what both the properties? Like in some condition, they may donate the electron, and in some conditions, they may even accept the electron. So, what you'll call them? Metals or non-metals? This was not clarified by Lavoisier, but now we know the clarification. Okay, now we know they are known as metalloids. What they are known as? They are known as metalloids. Okay, and there are n number of uses of metalloids, especially in electronics. Okay, which we are going to study further. Say there are large number of uses of metalloids in electronics. Silicon, germanium. Okay, these are used in electronics in a wide scale, and there was a revolution. Okay, the discovery of metalloids and their enhancement in their properties was just a revolution in the field of electronics. So let's come back to this. So this was the first drawback, that the metalloids were not known to this. And so what was the second drawback? The second drawback was, as the new elements were discovered, okay, those elements did not follow his hypothesis. The metals, his classification based on metals and non-metals were not obeyed by those elements. Okay, they were not truly the correct classification. Okay, and after this, then came the next classification was based on Proud's hypothesis. Now, if I talk about Proud's, he just gave a very simple hypothesis. Okay, again same like Lavoisier. Okay, what he said, that each and every element has been composed of a hydrogen. Okay, because at that time hydrogen was the simplest, and even right now if I say hydrogen is the most simplest element discovered because it contains only one electron, right? So what he said, that all elements are made up of hydrogen element, and if you want to calculate the atomic mass or atomic weight of any of the element, simply multiply by n into the mass of the hydrogen. But it was again not right. Okay, what he said, that, okay, I'll just make sure. Are made up of hydrogen, right? What? This was his assumption. Okay, now see, one thing I want to just make sure, like scientists they just go on assuming things, and when they clarify it or when they prove it that the assumption was right, it's been said as the theory or law. Okay, right? For example, if I talk about Newton, he saw an apple falling on the rain, he proved that it's gravity, so we say that it's a law. If he was unable to prove, that's just a waste. Okay, but not, I would not even say it's not waste, but it's not applicable or it's not acceptable by us. Okay, it's not acceptable by the world. But obviously each and every thoughts, each and every hypothesis put forth by the scientists are important, and if I talk about these, even these things are important in our further chemistry. Okay, so what he said, that each and every elements are made up of hydrogen, but it's not so. Okay, and if you want to, what he used to say, that if you want atomic weight of any element, okay, atomic weight or atomic mass, okay, atomic weight and atomic mass is one and the same thing, of any element is equal to n into mass of hydrogen, right? And what is n here? N is nothing but 1, 2, 3, that is the natural numbers. Okay, now he said that, and to some extent obviously he was right, there were many elements which followed this rule. If you want to calculate the atomic weight of sodium, okay, you can simply multiply by any of the natural number and then you will get its weight, that is the weight of the hydrogen, that is a multiple of weight of a hydrogen. But as the time passed on, the elements, new elements were discovered whose weight was not a whole number. Okay, the number, it was in form of decimals. Like if I talk about chlorine, its atomic weight is 35.5. Obviously you cannot find this through this formula. So again here his law has been disobeyed. Okay, it's not accepted. It was not accepted by the people, that no, if there are some elements which are not obeying his law, obviously his law is not correct one. Okay, now let's come another person. Okay, another comes the person, or if I say the scientist, the next person was Dobereiner. Okay, what his name was? Dobereiner. I'll just wet the chalk. Okay, it's quite rough, just a minute. Okay, so after Proust's hypothesis, obviously it was also been rejected. So next came Dobereiner. Okay, he's a scientist and he named his law as Dobereiner's triads. Okay, his law was named as Dobereiner's triads. Now why it was named as triads? Because from the name itself you'll understand triads means what? A group of 3 obviously. So that was only the interesting fact about his law. Now what his law says, like if you arrange the 3 elements, okay, if you arrange the elements in the increasing order of the atomic mass, okay, what will happen? The atomic mass of the middle element would be the average of the atomic mass of first and second. I'll write this thing on board. Okay, what are you saying? Like the atomic weight or mass. Okay, I'll be using both the terms. Okay, atomic weight and mass, don't get confused because it's one and the same thing, right? So atomic weight of middle element, okay, will be equal to the average of first and third element. Okay, just try to understand it. Okay, here we'll play somewhat with max. Okay, it's very simple max. You know what you mean by average? Okay, it's nothing but a mean. Whenever you want to find the average of any of the numbers, okay, any of a group of number, what you need to do, you need to simply add the numbers and divide by the how many numbers they were. Okay, how many numbers they are. Like for if I talk about here, let's take an example. Okay, I'll not complicate it, we'll solve example and we'll not do. If I talk about calcium, strontium and barium, okay, the atomic mass of calcium is 40, atomic mass of strontium is 87.6 and the atomic mass of barium is 137. If I add this both, divide by 2, I'll get the answer 88.5. This is just an approximately equal to the original mass of strontium. Okay, it differs by 0.9, so it's fine. Okay, you can say it is a Dobereiner's triads or it obeys the Dobereiner's triads. Okay, now talking about the last example, that is lithium, sodium, potassium. Okay, 7, 23, 39. If I add this both, 7 plus 39 will give me 46, divide by 2, that is the average. If I take 23, it gives me the mass of a middle atomic mass. Okay, now this was a law, this was a simple assumption made by him. Now still this law was not accepted. Now I'll just say you a reason, like we came across so many laws and we are going to come across many other laws, okay, many other laws which were rejected. So the criteria of classification, okay, the criteria which they chose for classification was atomic weight, which is not the correct one. Okay, atomic weight does not play important role in any of the physical or chemical properties of the elements. Okay, that was the reason they were continuously failing in their laws. If I talk about Dobereiner's, there were many elements which were further discovered or which came further, which is to not obey its law. Okay, now you'll say, sir, how will understand, because it's differing, it's still differing. Okay, so if it differs by 1 or 2, max to max I would say, if it differs by 1 or 2, like here the difference between is almost of 1.25, right? This is the original, this is the Dobereiner's triads. Okay, we calculated through the formula of Dobereiner. Even here the difference is about 0.9. So if the difference is almost by 1 or 2, you can consider it as Dobereiner's triads. But if it exists, if exceeds, okay, this number more than 2, no, it's not Dobereiner's triads and you need to disobey the law. Okay, the law is not applicable for those elements, and obviously it happened, the further elements were not obeying his law, and even his law was not accepted. Okay, now coming on to the next scientist, whose name was Newland, and his law was known as Newland's law of octaves. What his law was named as? We'll write it. Okay, I'll drop this. I think so you have noted down. These are the simple things. One thing I wanted to say, in exams the questions may be asked, you may be given the 3 elements along with the atomic masses, and they may ask you whether these are Doberanus triads or not. Okay, or there may be an example like they will say among the following 4 options which is Doberanus triads. So you need to make sure that you add first and last element divided by 2, and the answer you get is equal to the middle one. Yes, then it's Doberanus triads. Okay, don't worry, the atomic mass will be provided in examination. You are never required to learn the atomic mass of such big elements. Okay, such big atomic masses. Some basic atomic masses you must know, which we are going to see, and the more we are going to practice, obviously I ensure you that you will get memorized with it. Okay, you'll be familiar with those atomic masses which are required in the examination. Okay, but for these Doberanus triads you will be getting the atomic masses in the examination. A simple question may be asked from this part as well. Okay, there are questions asked from this Doberanus triads. Okay, a simple mathematical sum. Now coming on to the next, that is Newland's law of octaves. Okay, we'll rub it. Okay, so here is the next scientist. Even he tried to classify the elements, and obviously, see, let me tell you one more thing, like we are saying that they were ruled out, or they had some drawbacks, or they were not accepted, but they played a very important role. They played a major role in chemistry, and their things, okay, their concepts are used up in the chemistry. Though it was not accepted at the point for classification of the periodic table, but still we use their concepts, okay, to some extent in the chemistry. Now coming on to the Newland's law of octaves, yes, even he classified the elements based on the sur. Okay, there are 7 sur, or I could say it is 8 sur. Okay, I would say it is 8 sur in our music, that is sa, re, ga, ma, pa, dha, ni, sa, right? This is like we write sa, re, ga, ma, and the last sa. Okay, it has been repeated like the first sur and the 8th sur. Okay, if I talk about the first and the 8th are same. So same Newland said that if I arrange elements in the increasing order of their atomic mass, okay, again I'll repeat it, if I arrange the elements in the increasing order of their atomic mass, the properties of first and the 8th element are same. And obviously it was, okay, when you arrange these elements, the property of the first and the 8th element were same. And yes, you will find these elements in single group in modern periodic table as well. Okay, so his law was not in vain, but it was applicable only to certain elements. Okay, it was only applicable for certain elements, and for whose elements? The elements which didn't had any complications, in the electronic structure. Once the D block elements and the F block elements were discovered, his law was again not applicable over there. Okay, so I would say that his law was applicable only till calcium. Okay, after calcium, once the scandium, the D block elements arrived, there his law was not applicable. But still you can say like the properties of lithium is same as potassium, sodium, and same as potassium. Properties of beryllium, magnesium, calcium are same. Yes, properties of boron and aluminium is same. Properties of carbon and silicon is same. Properties of nitrogen and phosphorus is same. Properties of oxygen and sulfur are same. Properties of fluorine and chlorine are same. So the first drawback was what? What is this drawback? Okay, I'll rub this sur and all. Drawback, if I talk, not applicable for the elements after calcium, right? The elements which came after calcium, for those this law was not applicable. Yes, then slowly the inert gases were discovered. Okay, the inert gases, we are going to study what inert gases is. Just remember that this is a group of gases which hold a very different property, okay, which hold a different property. Now where they will be placed, because he has got only 7 rows. If I talk 1 2 3 4 5 6 7, where the inorganic gases will be put, will they be put in alkali metals? But they don't obey the properties of alkali metals because they have got their different properties, okay. If I talk about in modern periodic table, they have been given a different block, okay. They have been given a different entire row. So here again there was a problem that where to place the noble gases, and this Newland cannot solve this problem. His law was not satisfactorily solving the problem, so here his law was again disobeyed. So we have studied today some important laws, okay. So for today I would stop it for here only, and then we'll continue again in next lecture regarding many different scientists, and then finally we are left with one more scientist, very important, Mendeleev, okay. We are going to study about him, and his drawbacks are been asked in the examination, okay. In board examinations mostly they ask to simply write the drawbacks and the positive points of the Mendeleev's periodic table, okay. So we are going to study in detail Mendeleev's classification, though his classification was not accepted, but his classification was very, very important for the designing of modern periodic table, okay. So we're going to see about Mendeleev and the modern periodic table in our next lecture. Till then, goodbye. Thank you.